Okay, so I actually want to cover one different topic today because so far we completed manual testing except database. So once we are done with database testing, then actually, so you can say you are a manual tester. So you'll be able to maybe start uh, applying several places. There will be a lot of places, right? A lot of company, they don't need actually automation. So if they don't need automation, that means manual testing with database is sometimes good enough. So we'll continue automation again, but database testing and is database means is SQL, and also another topic in database. Let me check somebody. Okay. Okay. Hi, Gilma. Can you hear me? Okay. So let me check if, okay. Okay. So hi, Gilma. I think you joined like 2 minutes late, but I started that I will cover a different topic today so that you can say, okay, your manual part is kind of complete. But we will continue automation testing because automation testing has more practice going on. Like we'll cover two different framework, right? As I said, and we'll automate more and more uh, different type of websites with all other functionalities like calendars, drop down, as I said. So before going to more details in automation, I just want to complete manual part. And this database was the last part, I think. Um, there are so many topics, but database is one of the major topic that should be covered for your interview. So what is a database testing? If you think anybody can say anything from the just name database? So you see on my screen, right? There is a lot of information, right? Somebody's name, some country, some car company, right? Some sports team, numbers, height, weight, social security number, address, phone number, all kind of thing, right? They are actually part of data, right? I think database testing is one of the common testing you'll be doing as a QA. Every company you go, doesn't matter which domain, healthcare, bank, financial industry, information uh, technology is based on actually this database actually, right? So information technology, right? If you think about information technology, his name is information. It's all about all kind of information you are getting from uh, from everybody, every company, everything around you, right? You go to airport, right? Uh, Flying to some other country. They're checking your ticket number. They're checking that if you have all the necessary documents ready. How this check actually? All those data, right, are saved somewhere. So sometimes you go to DMV, right, to register your car or to renew your ID or anything, right? How they know that, okay, you are the right person? They have a database with all of your information like social security, ID number, address, name, right? You go to bank, you provide all the information, right? Your social security, date of birth, phone number, all other information, right? Address, your income, they save somewhere in the system, they save, right? And if you think that all of this information actually um, is part of data, right? All information together, actually, you can say those are data. And whenever you say somewhere those information stays as a, it's like a storing place, any place those data are stored, you can commonly say those are database. So database is a place where data can be saved. So one of the largest database in natural database in your brain, for example, your brain is a database. How you know that some person name actually, right? Phone number, face, address, you go everywhere. Like if you know some familiar person, you can talk to them, right? So your brain actually is one of the largest database, but this is a different thing. Like this is a biological database. But if you think about the information technology that we'll be testing, uh, so any banking domain, you see that all of these domain, um, you go to Amazon.com, right? Buy something. Somewhere in the Amazon database, your information are saved. After 3 days, when you are expecting a delivery, if you miss some delivery, right? You call customer service and they just ask you, can you provide me your order number? And from the order number, they can get everything, right? And they can give you all the information when, how it is delayed or not, and all the information they have, right? For example, you bought Amazon.com stuff last 5 years. If you go to Amazon.com profile, you will see history from last 5 years. How you can see those? They're coming from some database, right? Amazon has their own database, right? Facebook has their own database to keep your pictures and everything, right? Like Chase Bank has their own database to keep their customers' information. If you go to school like New York University, for example, right, or Queens College, or even you go to like Harvard University, right? Every university, college, school has their own database for their students, teachers, right? For their faculty member, right? Everybody. So database will be a big important topic. From interview point of view, from your work point of view, right? You will be dealing database every day as a QA. Is as a QA, and even you work differently, like DevOps or ASDET, or even if you work as like some any other information technician, analyst, you will be working with database, business analyst, right? Or even developer. So all of these information together are called data, and the place where this data is stored are called database. You can see the use of database, right? Your tracking system, right? UPS, FedEx, right? USPS, a lot of other companies. Your medical history in hospitals, right? You see that COVID numbers, how many people were affected in the US, worldwide, and some specific places. Every system has some database, right? So this database validation, right? Anytime you deal with those database validation, checking those data is correct or incorrect, the functionalities about a database will be called database testing or back-end testing. So back-end testing is a little bit differently used because back-end testing will be covered two different things. One is database testing like SQL, and another will be API testing. We will see API testing also. That is, I will be explaining actually a little later. But so far, anybody has any confusion that what is a data and what is a database?
No.
Today's class will be very straightforward, just understanding, but there will be practice also. There will be formula, how to retrieve, how to get data, how to check those data. But those formulas also very straightforward. Um, but you definitely need some practice also. So, okay, this picture is very important. From that, I said there will be two type of backend testing. One will be SQL or database table validation, and another will be API testing, application programming interface. I'll be explaining right now. Let me make it a little bit bigger, maybe. This is 100, 125 is good, maybe. Okay. Okay, so backend testing, right? I just explained testing, checking, backend side, right? Database. When you say backend testing, there is two component. Anytime you use any website, right? For example, Facebook or any financial domain or anything, right? Like you're going to Amazon.com, eBay.com, Macy's.com, Walmart.com. They always have any web-based application will have three layer of the application. So first layer is whatever on your screen. This one, you see that? The first layer, your screen. Anything displays on there, right? UI component, you see that like this file, whatever I see, you see, you use your phone, laptop, iPad, right? Anything you see on your screen will be front end layer. This is browser, this is front end layer. And there are two other components you actually don't see. You actually don't see, but your application is connected with. Like for example, if you go to Amazon.com, you see your profile here, but this profile is internally connected to two different other components. One is web server, another is database. So web server is, you will probably know now, like Amazon Web Services, this type of thing, right? So this is cloud computing. Cloud server, you don't see. This is cloud server. So for example, this application has a lot of component like coding, right? Like they have a lot of other business logics and everything, right? Where they stays, not in your laptop, right? Your laptop maybe will be damaged. You can throw this as a garbage, but it doesn't mean that it is gone, right? So your laptop is just a front end layer where you can see your details or information. But those information is coming from this web server actually. This web server is a cloud server. Different company actually sell those cloud space. And also this connectivity, right? Connectivity, these are server level connectivity. Like you type any URL. So those URL actually means your front end actually connected with some web server. So this web server actually has all kind of business logics, that how your code is working. So all of your application code inside web server. So now your web server is also connected with a database. Remember I said all kind of information from here. These information actually saved in this database. Different company has different database type. So you already probably know a lot of database. Like for example, Oracle, you probably know this name, Oracle, DB2, like Microsoft, SQL, Microsoft. So several companies have database and their job is to sell those database system. So if you go there, I'm going a little bit advanced. Okay. You see that there are several database management system, like Oracle is company's Oracle, right? MySQL is another company, Mongo database, another company, Microsoft SQL Server is another database company, but owned by Microsoft, right? DB2, another database owned by IBM, right? Access is another one owned by Microsoft. Different companies. So what different like companies does, like for example, what is Facebook? What Facebook does? So Facebook basically pays Oracle or maybe Microsoft or maybe IBM yearly some fee, right, to maintain their database. Facebook actually just use their service. For example, if you are renting, right? So if you want to move house, so if you have so much furniture, what you do, like you go to some storage company, you just rent some room, right? Just maybe 10 feet by 12 feet, one storage room, and you keep all the stuff there. So similarly, all of these company has their own storage system, They have places to store those data and organize those data meaningfully. And you will see that why those database management systems are very important. You see that this is an interview question. Why database management system are important? Because it makes you actually makes it easy. It makes it easy to maintain database. Like for example, if some new customer come to Chase Bank, and they will basically provide you all the information. Now, the bank are actually just collecting your information and giving in some place from front-end layer. But for example, if this is the Oracle system, so that will be Oracle system's responsibility, which table this will be going, right? And if this data is correct or incorrect. Like for example, you have social security is 9 digit, right? 9 character long. So if somebody give 11 character long social security from USA, that means what? That means these are incorrect, right? So this database management system also will have those kind of validation process. If your social security length is correct or type is correct, like zip code, right? US zip code is just simplified numeric number. But if you go to maybe UK, England, they will have 5 digit, but they will have alphanumeric mix, right? In Canada, maybe also. So similarly, database management system will be checking all type of data. Like for example, you said, okay, first name, last name. First name should not be more than 30 character long. Last name should not be more than 30 character long. If somebody give like 50 character long first name, it will not be accepted in database. So those, you see the data management system, they will be actually taking care of those through their software. So special software program, you see that database management system will be special software program that helps user create and maintain database. So it will be easier. It will be easier. So if you want to delete some data, some customer come to Chase Bank and said, okay, I want to close my account. What are you going to do? So Chase Bank employer or banker doesn't have to go to database and delete every table. There is like 5 table has this customer information, right? But that will be done through this DBMS, database management system. So you'll just give this maybe social security or account number, and maybe you can delete it easily. Backup, right? You see that importing, exporting, handle security, right? Software application, all of this is basically helpful reason why database management systems are used in different companies. So I'm going back to top of these slides actually. So okay, so this is database, as I said, right? Different company own different type of database, and the software used to connect and work with this application web server. You see that all of these. So this database will be connected with web server, right? Through database management system. So you will be giving information from front-end layer, and it will be going through web server, and database will be working accordingly. So as a QA, you have two things. You will not only check through the web server, you will also directly check to the database. So you see that when you check directly, when your front-end layer, right, connected with database directly, this is a 2-layer only, right? So right now you are going through web server. This is 3-layer, but when you just avoid this web server, that is a 2-layer. So there are several application, 2-layer application. Even if in your laptop, right, your storage system is 2-layer application. So for example, you're in your phone, right? Anytime you take a picture, it is a 2-layer application. Your photo gallery is a 2-layer application. So do you need internet to just access your photo? No, right? You can go to your file, your library or album, and you just click one photo and this photo will be open. You don't need any internet for two-layer application. So two-layer application does not require internet. This is one of the big difference. But three-layer application, you need internet to work with. So if you don't have internet, right, you cannot log into your online banking or online Amazon website or online Netflix, right? So you definitely need website. Basically, you definitely need internet connection to access those websites actually. So whenever you need internet connection to access those websites, those are three-layer application. Whenever you don't need internet connection to access those application, and basically those databases directly connected to the front end, that is a two-layer application. So this is one of the interview questions also. And as you see here, right, this is called two-layer or two-tier architecture. Can somebody give me one of the example in your phone system that has two-layer application? Another one. Hello, can you hear me?
Yes.
Just give a example. So you have, for example, a lot of people are tracking your steps, right? Heartbeat, how many miles you walking, right? Remember, in your system phone has this. This type of application is also two-layer application. So anytime you walk, right, it counts steps, right? Anybody just used any step challenge or anything on your phone?
Yeah, I did recently.
You don't need internet, right, to count steps on your phone.
No.
This application is two-layer application. You don't need internet. But if you say, okay, weather.com, if you want to use an application that weather.com or eBay, all of the sudden, if you don't have an internet, if you try to use those, you cannot use those because it will not update accordingly. Because to check weather, like if you want to check like weather in Sydney, Australia, how they will know that what is the weather in Sydney? First, it will go to web server through internet, and through web server, it will check the database. Without going to web server, it cannot check like this type of three-layer application. Or you want to buy a product from Macy's.com, you definitely need to go through the server, through www like Macy's.com, right? Something. Without internet, you cannot buy. So this type of architecture, you will see this is a three-tier or three-layer architecture. All the web-based websites, you can say three-tier application. So there are a lot of advantages and disadvantages for two-layer versus three-layer. So you can see that three-layer has more advantages than two-layer because it's most faster, right? Is flexibility, right? Performance, reuse, data integrity, like security, all of these things. Actually, web three-layer application has more. So today's class will be mostly about this part, this front end with this part, and we'll be covering another class in the future, maybe short class, that will be this one will be covered with this. So there are two type of testing, as I said. Whenever you go directly to database, it will be database testing. Whenever you go through application layer or server, it will be backend testing, and it will be also API testing. So I will explain what is the difference between these two. So far, anybody has any confusion? What is two-layer application versus what is three-layer application, and how they're different?
Hello.
Okay, so these are like some more definition that what is a client layer, what is application layer. I think I'll share this document with you. So I already covered Okay, so this one, right? API versus database testing, two main branches of backend testing, right? will API will be applicable for three layer of application, right? Remember I said API, it should be going through the server, and you need internet connection for API testing. But database testing, you don't need internet connection because you are directly connected with this data source. So, okay. So database testing is also part of three different type of testing. You see that we already covered this maybe beginning of the course. Functional testing, non-functional testing, structural testing. And we will cover all of these today. We kind of covered this one. What is a data, right? What is database, right? So what is data, right? Anything you see around you, right? Anything you see around you, part of data. Your family member is part of your data. Your income, your address, wherever you live. You see everything around your friend circle and everything is education, everything is data. Somewhere in the system, all those informations are present. Everybody in this country, right, has social security, for example. So social security is a big source of data, right? Like you see that IRS, how they work actually, how they know that like this person made 500,000 or this person made 50,000 or this person owe 20,000 to IRS or this person will get 5,000 from IRS as a refund, right? You see that all of this information is coming from database. So you will be dealing database every day as a QA, or if you work as a IT associate or specialist. So as I said, what is a database? Database can be your phone book, right? You see that there are some examples, right? Any collection of related information, your tool list, your shopping list, right? Your banking domain. Database can be stored in different ways. You see that like simple way, like you have a notebook, for example. A lot of people has a notebook where they write important people's address, phone number. So it is changing, right? Like if you think about like 20 years ago, right? Not so much like phone use or iPhone, for example, iPhone or this type of device, right? Not so much. What they used to do, they used to have notebook, phone book, right? This type of like some books or something that they keep all the information on paper, right? This is also a database. It's a physical visual database, right? In your mind, I said your brain is one of the biggest database, right? On computer, this is the one of this for recent time. So on computer, and if you think about on computer, now this is more advanced, is cloud based, right? If you see um, Apple, for example, Apple will always provide you like services like you need 5 gigabyte storage, you need 15 gigabyte, you need 50 gigabyte, 100 gigabyte. Where those storage, do you see those storage? Those are cloud based. You don't see actually. Those are cloud based. And cloud computing is one of the important topic, right? Everything is cloud now. Everything you see, information technology is cloud based. So database system, I already explained a little bit. That is a special software who maintains your database, basically storing data, security point of view, all the other aspect, logics, right? They actually, those database management system job. You want to create anything, you want to save, you want to delete, you want to update. This is their job, database management system. And as I said, different company, if you go to some interview process, right, they will be asking you what database you used in your company. You can say I used Oracle. Maybe you can say I used DB2 from IBM. Maybe you can say I used Microsoft SQL Server in my recent project. So you're not going to use all 8 or all 12 database in your company. Every company has maybe 2 or 3 maximum database. Usually most of the company has maybe 2 database, but sometimes they have only one database. Like my company has 3 databases where I work. They have Oracle, they have DB2, and they have this one, PostgreSQL SQL. This is another one, but they actually work exactly same. You will see that like in maybe 10 minutes, because formula to write in database and to get the data from those database will be exactly same, or maybe 99.9% same for all of these database. So how database management system works actually? You see that you are going to Amazon server. So this one is talking about now 3-layer application, how 3-layer application works with database, right? Remember I said you are providing information here from the front end. Your front end is actually directly connected to this. So whatever you're writing here, right, it's coming here. So now this application will be dealing with the database. This is API testing. And another one I said, the database testing or SQL, that you are not dealing with this layer, you are directly dealing with this. Okay, so this is one of the interview questions also, that how database management system actually works with your data and database. So you have a database and you are giving your information, right? So this system will basically use CRUD. This is this is the word actually you have to know. So what is C means, what is R means, what is U means, what is D mean actually. So API testing, database testing, both backend testing, right, will be using exactly same thing. So anything you do, right, with the data, you basically follow this. And C means create. Anything you do with data, you actually follow this 4 word, either create or either you read. Read means get, means if you call to some customer service representative, right, what they do? They ask you, can you give me your account ID? So they search with your account ID. This is basically search option. Read means search. Update, right? Now you are moving from New York to California. You call to Chase Bank and said, okay, I want to change my address. What they do, they're not deleting your account, or they're not canceling or doing anything. All they're doing, they'll be updating your address, right? Maybe phone number. So this is you, update. Anytime you dealing or updating your data, that's you, right? Update. Delete, right? Now you have a TD Bank account in New York. You are moving to California, right? California maybe has no TD Bank. You are not dealing with TD Bank anymore. You probably will be dealing with maybe Wells Fargo, their local, or something, maybe Chase again, or Bank of America. So you are going to TD Bank and saying that, okay, I want to close my account. So they will be closing your account. So this situation is delete, means you are closing your account or you are deleting all of your information from their database system. So create, anytime anything new information you add, means new customer, new student, right? That will be create a new account. Read means search, right? Or get information or check information. Update means anytime you want to update your existing account. Basically, you are updating your existing account. Delete means you are deleting or you're closing account or anything, like deleting information from the database. So this is actually how it works. And your database management system basically work with these 4. You see that Amazon.com will interact with the DBMS in order to create, read, update, and delete information from the database. 2 types of database, relational database and non-relational database. So will be for, okay, so for your course, right? For your most of the QA course, 99.9% time that you are actually dealing with relational database management system. That means you will have table, and this each table will have information. So it is a table format information. So we'll be concentrating on relational database management system or relational database. And relational database basically SQL, as I said. Anytime we will be dealing with database, we are talking about relational database system. So now you see that this is one of the example of relational database system. Any information is stored in like a bank, any information is stored in like in your school, college, university, right? That will be stored in a table format. In some table, we'll have specific information. You see that there is like two table, for example. One is student table, user table, right? We'll see more actually. Database queries, as I said, there are some formula. Formula will be very straightforward. We will see, we'll review those now. So those queries, right, will be used to search data. So you have to manipulate those queries. Even though those are straightforward, if you actually don't practice, you actually cannot give the right answer. You have to practice. So we will practice a little bit those queries today. So those are database queries. So database queries will be used to perform CRUD. Create has a query or formula, read has a query or formula, update has a query or formula, delete has a query or formula. But 80 to 90% job as a QA will be dealing with R, read. So read means you are checking your data on your screen. So as I said, 80% to 90% time, this is the one you are concentrating on. But for testing purpose, right? Sometimes you have to create your test data. Sometimes you have to update your test data. Sometimes you have to delete your test data. So as I said, 10% to 15% time, maybe you have to use these three queries also. But as I said, between 80 to 90% time, just deal with R, read. And read will be actually select. We'll see that actually a little later. So wrapping up the information about data, database, and database management system, right? You can say database is any collection of related information. This is just summarizing what we just covered so far. Computers are great for storing databases, like recent year, like cloud computing and computers. Database management systems make it easy to create, maintain, and secure a database, right? As we already explained how. DBMS, right, database management system, allow you to perform the CRUD, right, CRUD, create, read, update, delete operations, and other administrative tasks. Two types of database, relational and non-relational. Okay, relational database uses SQL and store data in the table formats, table and row, that will be concentrating on. And non-relational data is stored data using data structure. Okay. So this is one of the important topic for today, relational database management system and how it works. So basically database structure is table format. Table format, as I said, if you just search, if I go here and search database table, example, for example, or diagram. Okay, so if I go to image, for example, now if I open just one, Just one example. All of them are same kind of. Really, go there. It's okay. Okay. So you see that this is one of the, everybody can see my screen, right?
Yes.
Okay. So this is just one example of database for maybe some small companies. This database has only like 7 tables, right? But in real life, when you work in some company, that company's database will have probably like 50 tables or 30 tables or 40 tables. It depends, right? It depends company to company. If company is big, there'll be more tables. There will be more data, right? If company is small, there is maybe less data table, right? So maybe you see that this is one of the example. This is one table. 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 This is one table, right? If you go to example for school database example, if I just go there, okay, this one is a good one actually. You can see actually. Oh,
the issue I would say we have in
that's
the
a video actually. This is, I don't want to check the video now. Okay, so just this one checking. You see that this is something similar to school, one of the school, maybe. Staff data. Staff has a data here, right? Staff ID. Staff means all of this teachers, right? Class data, right? Like how many classes there. If this is like high school, right? If there is like maybe from grade 7 to 12, right? All of this information here. Grade entity, right? For each student, for each exam, right? What is the grade they are getting? Information like where, like their parents' information, like each student, right? Have their parents' name and other thing, address. There is a lot of table, right? Each table has a purpose, right? So, and they are somehow connected to each other. So since they're connected to each other, that's why this is called relational database management system. So each table will be related to another table somehow. Somehow related means, you see that if you go to grade, right? Grade data, and if you go to family data, maybe, or maybe this student data. So pupil means their meaning student. So student and grade has a common place, right? So you see that pupil ID, student ID actually. I don't know why this pupil is term. And there is also pupil ID, right? So you see that these two table is somehow connected. They are connected with some information. So this table information is connected with this table information. Again, this table information is connected with this table information. You see that class ID is connected with this ID. So now we will be actually checking our note. Our note also have some information. For example, this is student, right? Student table. This is just like 5 here, but in real life, if you go some college or university, you will find their student database has maybe 10,000 students. And now those 10,000 students may be having, they're having different major, different departments, right? That's another thing. Like if you have a student, just the student table, that student will have all the active students. So there may be two tables, right? Students, active students, and students maybe who completed their courses, bachelor's, right? Like alumni, right? They're already done. They're not current student, the old student. They're called alumni, right? So you see that different purpose, different table. User, right? For example, if you go to Gmail user table, probably you will have like similar like of database table, like Gmail ID, password, right? So here you can see password, but in real life, password will be masked. Password is sensitive information. This is personal information, right? So it will be masked. You cannot see somebody's password easily. There is some technique also that you can actually convert the password to real. And usually if you see some password here in real life, that will be either masked or some random number, some graphical number, actually some other number, not the real password. You should not see the real password in real testing. You see that sometimes types, right? Like for example, you are creating a WhatsApp group. Not everybody is admin, right? Maybe you are admin. There are 50 people are in this group. Maybe 3 people are admin and 3 people just read access. They don't have access to change anything. They can just see, read. And now all of a sudden, if the people who are admin, they can just remove those people, right, from the group. So you see that all of these functionalities, right, will be listed in the table also. You see that student, there is maybe department table, which student is taking which major, right, or all of this. So this is another one, for example, student roll number, student name, student, the course he or she is taking, right? So these are information is part of your table, and end of the day, those are part of your relational database management system. So how they work, as I said, database will be actually based on multiple tables. So this is maybe not interview question, but this is basic information you should know. So each table has different type of component. Like for example, if you see left to right, if you go left to right, and this is called horizontal, right? Means flat, left to right. This is row. This is called row. And if you go top to bottom, this is called vertical, right? This is called column. So row and column, two important component each table has. So for example, name, all of this name in each column, all of this major in each column, all of the student ID in each column, right? And row, right? One, Jack, biology. So each row should be unique. So if you go to student, right, that row should be unique, not major, not the column. Column should not be unique, except one column should be unique. Each table will have one column that should be unique, right? If there is there is a student column, if a school has 500 student, a 500 student name, right? 10 people can have exactly same name. 10 students can have first name Tom or last name Jack, for example. But all the 500 student will have a unique student ID. So you see that student ID is very unique. So each table will have a unique column, and that column will be primary column and primary key. That each unique column will be holding the primary key. So primary key will be unique. Your social security is a primary key. Your driving license ID number is a primary key. If you go to bank, your bank account number is a primary key. If you register in a school ID is a primary key, right? So those are primary key. So primary key should be unique in a table. And as a QA, this is also part of your testing, making sure that primary keys are unique. So all of the sudden, if you see there are like 3 student ID 3 has for 3 different people. Same student ID for 3 different people. That's a problem. That's a defect actually. So you will be logging this defect. Okay, student ID is assigned same student ID assigned for 3 different people. That's not expected, right? So you see that even though you are not doing any functional testing, this is actually directly going to the table and checking each of the values. So you have to sometimes just go to the table. You probably basically, if you go to some company, right, as a QA, you will have access, directly go to this database. You will have access, you will have database system access like user ID and password, and you can go directly to this database and you will be seeing that this database has maybe 100 tables, right? You will have access to each of these table. Sometimes there are maybe 100 tables, but some tables are very like highly secured, like personal information. You will not be maybe provided those tables. Maybe there's 20 table, you will not have access. So database management administration, sometimes just database administration. This is another group of people, sometimes developers, they are part of developing team. They will provide you the access to specific database table. Sometime your manager will give you specific access. Sometimes DBA will be asking you, get the permission from your manager or your lead or whoever is your reporting boss, right? So that DBA can give you specific permission. So not necessarily you have access to this database means all the table you can see, you can go and check all the tables. You will have definitely specific access. So these access also will be maintained by DBMS. You see the database management system. This will be also important because they have a specific software that so specific people can have access to a specific table and a specific database. So this is a package, DBMS, database management system, Oracle, right? IBM, Microsoft. This system actually taking care of this process. So each table has 2 things, right? One is row, one is column. And as I said, you should have one primary unique column for each table. This is mandatory. This is mandatory because without a primary column, right, primary key, right, your database is useless. You cannot use this database, right? If some database has same social security number, right, for social security column, can you use it? Like how you will be using it? IRS will be confused that which one is the right person. So basically is data integrity. It's part of data integrity. So you should have one primary key that will be specific and unique identifier for a specific people. So if you go to IRS, what is the specific identifier? Your social security will be the identifier, right? 100 people can have same date of birth. 100 people can have same address. Like if this is like big apartment building, right? 100 people can have same maybe city. So you see that all of this other information, last name, first name, thousands of people has same name like Mohammed. Millions of people has same name as Mohammed. So if like IRS want to search with the name Mohammed, they will find maybe like millions of people. But if they search with one specific social security number, they'll find one specific person. This is very, very unique. So you should have some unique identifier. And this unique identifier basically is called primary key. You will see this in the future because this primary key will be very important. And this is also interview question. What is a primary key? and we'll cover this more. As you see that here, each left to right horizontal, those are called rows. Top to bottom, those are called column. And if you see just one box is a field. So another thing, entity and attribute. So table, right? So table has another name as entity. Sometimes they will be saying you there are 10 entities in this database. That means there are 10 tables. What is attribute? Attribute is another name of column. So if I say in this user table, there are 4 columns. I can also say there are 4 attribute. Means email is attribute, password is attribute, data created date is attribute, type is attribute. So specific criteria, those are attribute. So if you think about human, right? Human has attribute like height is attribute, right? Somebody may be 6 feet, somebody is a 5'5", somebody is maybe 5'7", those are attribute. Phone number, your phone number is a attribute of you. Your address is another attribute, right? All of this information, your income, attribute means column. Different name, but column and attribute same, entity and table name same. You see that sometimes it will be saying relational database management system has another name also, entity relational database system. So it can be entity relation also. So entity means each table will have common criteria. See that it says attributes, each of this column is attribute. Each of this table is entity. You see that, as I said, this is just basic information. I don't think so anybody will be asking you what is entity in interview. This is assuming that you already know. So now this is one of the important topic. Primary key, foreign key, sometimes composite key is less important, but these two very important for database queries when you work. I already explained what is a primary key, right? A primary key is a column in a table that uniquely identifies the rows in that table, right? Remember, I already explained a little bit that primary key cannot be duplicate, basically, right? You cannot have 5 social security, same for, what is that? 5 different people has same social security. You cannot have this. This is against the data integrity. It cannot be happen actually, basically. So this is primary key, uniquely identifier. Like for example, if you go to order table, order ID will be maybe primary key. If you go to your account in Chase Bank, account ID will be the primary key, something like that. You'll see that more. You see that the values placed in primary key columns must be unique for each row. Now, no duplicates, and also cannot be null. So cannot be null means you cannot just keep this blank. If you say that, okay, customer number is a primary key, your table must have all the values. Whenever you say primary key, right, it cannot be empty. Your address can be empty, your phone number can be empty, but your account ID, right, your social security, right, your maybe driver license, whatever is the primary key, your student ID, they cannot be empty. A student table will have to have a student ID. An account in a, if you go to like Bank of America, and if you are a new customer, if you say you are a customer for Bank of America, you must have a customer ID, means account ID. If you don't have account ID, you are not a customer of Bank of America or any bank. You should have some account ID. So this is one of this thing. In addition, nulls. You see that nulls means empty. There is no value. Are not allowed in primary key column. This is probably interview questions that sometimes they want to ask, okay, what is the specific criteria to become a primary key, right? So these are the criteria. Cannot be duplicate, is a unique, cannot be null, right? Those are specific criteria. You see that? This is one of the example of table. These are only like 4 or 5 row, doesn't mean 4 or 5 row. This can be like 1 million row in the database, maybe 100,000 rows. Social security number, clearly there is a primary key, right? All of these 5 people can have same first name like Mohammed, right? Same first name like Tom, John, right? Like this. But this is a primary key. Another one is foreign key. This will be very, very critical and one of the most important one when you actually test database validation, do database validation. Foreign key, you have to figure it out, right? So this is also very similar to primary key actually. So foreign keys are column that point to a primary key column. So basically foreign key is the connector between two tables. If you ask me what is the foreign key, the short answer is foreign key will be the connector or the common column between 2 or 3 tables. If you want to check more than one table, you have to figure out what is the connection. Where is the common connection between these two tables? So now, if you see that I am connecting two tables, one is customer table and one is order table. Now I have to figure out which column actually common in both tables, and whatever is the common table is the foreign key. If you see the customer table, like for example, Amazon.com. This is Amazon.com customer table. This is Amazon.com order table. So yesterday you ordered something, today you ordered something, maybe 5 days ago you ordered something. All the order information will be listed here. But customer ID, customer name, maybe address is there, right? Or phone number is there. So if you say, I want to check how many order you made last 30 days. If I want to check as a customer representative or somewhere I'm working in Amazon, or maybe in your front end, right? Your application, when you go to Amazon.com account, you can see last 30 days how many order you created. So what you have to do, you have to connect these two tables and check the database. You see that when you connect these two tables, you must need a common column as foreign key. You see that customer table, customer number is the primary key, right? Order table, order number is the primary key. But order table also have another column, that customer number. This is not a primary key here. If you declare primary key here, it cannot have same value, right? You see that 42, 42, 112, 112, they are same number, right? Because they are not primary key here. This is a foreign key. And foreign key is basically connecting these two tables. Order number is primary key. So how it is working actually, see that if you order today, right? There is a order number will be created. If you order tomorrow, there will be another order number will be created. And you maybe ordered like 2-3 days ago. You see that in like last 4 days, you made maybe 3 order. But these 3 order, your customer ID is exactly same, right? You are not changing your customer ID. All you are changing your order ID. Every time you are ordering a new product, excuse me. So a new order ID will be created, but customer will be exactly same. So you are basically filtering now. Okay. So for example, your customer ID is, your ID number is 42. So how many order 42 created? Basically you created, if you filter, you created 2 order. Maybe there are more. If you check that whole database, maybe you created like 12 orders last 30 days. So now if somebody want to create a report that, okay, please create a report for customer ID 42 with name, address, and order details. This order table does not have name and address, right? but this table has. So basically, you are getting information from two tables. Whenever you want to get information from more than one table, you need a foreign key. So between these two tables, which one is the common column here? Can somebody tell me? Customer number, right?
Yeah.
So customer number is the common column. And common column customer number is basically, it is a primary key in another table, but not in order table, right? Excuse me. So this one you have to figure out which one is foreign key. And this is when you actually practice SQL, you definitely need to figure out the foreign key. So foreign keys are columns that point to primary key columns in another table. You see that? So for example, order number is the primary key in the table orders, and customer number is the foreign key in that table that is pointing the primary key of customer table. So this part, anybody did not understand? This one actually have to understand that the relation between primary key and foreign key and how they are related actually. So this is like 40% of SQL here actually of this today's topic. Any of you actually did not understand this one? Hello?
I understand. I understood.
Okay, so if you are clear about foreign key and primary key, then I can move forward. Okay.
Yes. Yes.
Okay. So Gilma, you are okay?
Yes,
Okay.
thank you.
Okay, so you see that again, another example. This is employees and order, right? That employee number is foreign key. Employee number is also here, right? There is a two candidate of primary key. So in real life, you probably not gonna see this type of table that has 2-3 primary key. Means this table can be divided also. So this also unique, this also unique. You can use one of them as a primary key. You just have to declare. So this table has 2 primary key candidate, right? One of them can be primary key because employee number also unique, social security also unique. So one of them you can declare as a primary key. Here, right, order number is primary key, but employee number is the foreign key because this is the relationship, right? You see that making a relationship between these two tables? Basically, foreign key is the column that makes relationship between two tables. So composite key is another example, basically like this type of thing, right? So you can actually select these two and can write both of them together as a composite key. If you see here, composite key, see that two column together is declaring as a composite key. You're not going to use this in real life too much, just for interview purpose, maybe knowledge purpose. A composite primary key is a primary key consists of more than one column, right? Instead of one, you just declaring both of them as a primary key. So whenever you declare both of them primary key, that means you have to have all of these value unique. And also you cannot have duplicate and cannot be blank. Those values cannot be blank. Date of birth can be blank, date employed can be blank, but not these two columns. So basically two column together will be composite primary key. Normalization this is a testing process that sometimes you will be involved in a testing as a QA. And what is that actually? So that means sometimes your company will get data as a chunk, like it's a big chunk of data that is not finalized yet in the table. So through the normalization process, database will be actually cleaned. So this is a cleanup process in database. So there are 3 steps: first normal form, second normal form, third normal form. So for example, today your company, like for example, you're working some company, they got like all the data together. There is no separation of city, no separation of state. They are getting data as an address together. Like there is no specific column for city, no specific column for maybe zip code, right? So now this is in first normal form. You will be creating, okay, making a little bit bigger this part. Okay, so in first normal form, right, you see that you are just trying to organize this in a table. But even though you are trying to organize in this table, you can see some columns are empty, and some rows are empty, and some column has multiple type of information. So if you have one column address and another column is price, right? This cannot be, another column has 32, the number, total number, right? Address, number, phone number, they cannot go in same column, right? This is definitely not the right way to write table. So this table is basically is not a perfect table. You have to clean this table. So this cleanup process is actually will be done through this normal form. This is called normalization. So normalization is a process to minimizing redundancy from a related relation or set of relations. So you can say normalization is a process to cleaning up a table and make it more perfect. So basically you are getting rid of all of this garbage from the table, eliminating, right, all the unnecessary stuff. Or sometimes you have to break down information. For example, if you get the address, right? So each address has like 4 different components, right? Your house number, then street, then city, then state, and then zip code. You see that there is like 4 different component. Sometimes your house number will be with your street or maybe post box, but your city, state, and zip code must be separate, right? For example, for filtering purpose. So now Amazon is thinking to check how many customers they have from state of Alabama. So what they're going to do? In the database table, they have a column named state, right? So they will be just filtering, okay, find all the people, number of people where state is Alabama, or find all the people where state is Minnesota, right? Or Virginia. So this way, so to do this, you have to clean your table, right? You have to just clean up your table. So through normalization process, you basically clean up your table, make the table more perfect and useful. And as I said, right, ultimate goal when you create a table, every table will have at least one primary key or at least one primary column. So make sure your table will be clean enough and your table will have one primary key so that this table will be useful to use, right? So in first layer of normalization, get rid of all the columns that hold the same data. Remember, so ultimate goal, you are cleaning up, because in the second layer, you have to figure out which one is the primary key. You see that? So in the second layer, when you are cleaning up the duplication, you can now figure out the primary key. Split up data, that can be, you see that splitting up, I said, if you have address, like it's a big long address, you can split up address as like state, city, zip code. What else? You have a name, right? Maybe you can split up first name and last name. All the time you will see first name and last name, every database, everywhere, separate. Maybe you have to, somebody gave you maybe other information, right? Income and income type and how much they makes, right? All of this, right? So you can actually separate them, like type of income and the money. You see that all of this information is part of your first layer of normalization. Second layer, if you are figuring out this cleaning process, after that, just make sure every table will have a primary key. So declaring the primary key is the second layer. What is the third layer? Is splitting up. If it's necessary, make it one table to two table, two table to three table, if it is necessary, but you cannot have a dependency. As I said here, right? Where is it? Oh, this one. This table easily can be broken down into two tables. One table with employee information, right? Employee ID. Another table can be with social security and basic information, right? And employee ID, employee table can have the primary key, employee number, social security. If not necessary, it's okay. So now if you go there, right? This one making it bigger more so that you can. You see that this table, first normal form, you are doing this to first to normal form here, right? This table, actually, you cannot see what is there. Actually, you don't even know what is there. Actually, customer address, what is 32? Actually, you don't even know what is 32. Product ID box. Box is not ID. Chair is not ID. This is product like name of type, right? Product type maybe chair, right? You see that this can be easily broken down into two different columns. This can be easily broken down into two different columns. This is also two different columns. Here I can see easily 64 Bone Street, one column, city, one column, state. I don't see any state also here. Like this state is missing. Maybe another table will have zip code, right? This is name. You can also break down these two names, first name, last name, right? Customer ID. I see customer ID and order ID in same mix and match. So you can actually break down. This can be broken down into at least 4 table. I can clearly see there is a 4 table information here. How you can see 4 table? One is anything related to order. That will be order table. Another table will be anything related to customer. That will be customer table. Another will be anything related to product. That will be product ID or product name and this thing. Sometimes another table you can make it inventory, final inventory, how many remaining, how many not remaining, is all of these specific 3 to 4 table is there actually, right? You can easily create 3 to 4 tables. Breakdown and 3 to 4 tables, and you see that how they are related and why they're called relational database management system, because even though you're breaking down, they will be related to each other somehow. It's their information. All of these table will be related to each other. That's why it is called relational database management system. And here they're still cleaning up, right? But it's not done yet. You cannot say order number is a primary key because you see that a lot of duplication. It's not unique. 1, 1, 2, 2, 2, 2, 3, 3. They are not unique. So you can still cannot declare. As I said, you should definitely create Here from this table, just make two tables. One is order table, one is product table. So then order number can be unique, product number or product ID can be unique. So anybody actually did not understand this process, normalization is basically cleaning up your database. And as a QA, you have to sometimes check those cleanup process as part of QA process. You have to go to database and check if this table has primary key has duplication or not. If primary key anywhere is empty, this type of thing you have to actually test. So far, everybody is okay till normalization.
Yes.
Yes.
Okay, so now we will be covering SQL for rest of the day. SQL is the query that you'll be using. So before actually going to SQL, I will suggest, so we'll be using actually W3 School for all the basic practice and interviews, right? But we also have several courses in Udemy. But I will suggest one of these YouTube video. This is like 3 hours long YouTube video. There are two instructors, they cover exactly same thing. So just watch one of them. If you watch one of them, you will be basically good to go with anything related to SQL interview. It's like I'm kind of summarizing whatever they actually covered in 3 hours. So far as whatever I summarized. So if you just, for example, if I just actually I can directly go to his video, right? One of his video, for example.
Hi, my name is Mosh Hamadani, and I'm super
that
excited to be your
3 hours
instructor.
and 10 minutes.
In this
Right?
3-hour course, you're going to learn everything you need to get started with SQL or SQL. First, I'm going to give you a 3-minute introduction to SQL. Then we're going to install the necessary tools.
So he actually installed a database management system in his laptop, right? So if you want, you can do that, but it is also not necessary at this moment. You can still practice without this database because, as I said, I will be using W3 School. So W3 School has similar database IDE where you can practice. Even there are a lot of actually website that where you can practice. But as I said, W3 Schools is a basic for interview is perfect. You don't need more than W3 School actually. But definitely I will suggest watch at least one video about SQL and database backend testing, database testing. So you'll be basically know all the necessary thing that you can face at real work and also for interview. So now I'm going to W3 School. Just what we are actually doing. Okay, so I'm right now in W3 School. W3 School SQL. So I think in the past, I said you can go to W3 School Java for practice, right? Remember, Java was another one we sometimes used as a reference. So W3 School is a big reference website for everybody, developers, QA, as that anybody is in IT, information technology, working with any kind of programming concept, they have everything. All the programming language is here for practice and also all the concepts that you need for the interview also. So what we are doing, SQL, right? So nobody will be asking you what is this SQL, right? SQL is a structured query language. SQL is a standard language for that will be used for all the database management system. Remember I said database management system. These are like 8 examples here, right? So they are using the language SQL. This is just a simple formula. Now, I said there are 4 types, right? CRUD. C is create, R is retrieve, and R is basically select. You will see R means actually in SQL, any queries starting with select is part of R. And I said 80 to 90% time, you are using this query. You are using this query. So this query basically, select statement, I'm going to. So in regular math, right, you say formula, right? A square minus B square equal to A plus B times A minus B, right? You see that like maybe in your school, you did some kind of algebra formula. This is in regular math, in algebra formula or calculus formula, right? But in database management system, this will be called as syntax. You see that syntax, SQL syntax, exactly same thing, right? Is syntax means SQL formula, or you can say SQL query. In QA, that will be used sometimes query, QUERY, query. Query means also is kind of formula, is a format of code that is called either syntax query or just plain. If you just you want to say plain English, is just a formula to access the database. So it always start with select statement. You see that select statement, how it works actually. So this one actually is your 80 to 90% of SQL. Now this one will be modified. Modified means you will see here that how you can use the same formula 50 different way or 100 different way. Depends, right? Depends. Like you can, the formula is exactly same. The syntax or query is exactly same. This is the select statement. So what is this select means? So now you are calling to help desk, Amazon.com. Now they are asking you, can you give me your order number that you're looking and you're actually want to know the information. So you are giving the order number. So their database in order has maybe 2 million data. And but the help desk person will search only a specific order, right? So what does that mean? That means they have to give some kind of condition, right? So they will say, okay, select, you see that select, always start with select. Select order details. So instead of column 1, maybe order details, or column 1 maybe status, right? It depends on, this is just like example. So select order status from order table. So this is a table name, right? Order table, it depends, right? Remember, there are a lot of table name. Now you have to give where order ID equal to 1, 2, 3, 4. So when you say order ID equal to 1, 2, 3, 4, remember order ID is unique and a specific ID that cannot be duplicated. So this is only have one row. One order ID has one row. So now if you give here order ID, that means now you see that you are giving some condition. So select from is always same. If you see this formula, right? This formula is always same. But depending on your search, depending on your purpose, right? You are modifying this formula. You are just modifying this formula. So before going to select, right? I want to just show you a little bit of create, update, and delete first. So if you go to, you see that create. So this is one of these. Most of the time, you will never create a table. 99.9999% time. This is developer's job. You are not doing this actually. QA will not create any table. QA is not creating any table. or QA is not creating any database actually. QA is not creating any database because this is a different role. This is a DBA, database administration. This is another group. Is like the QA is a group, development team is a group, business analyst maybe is another group, DBA is another group. Database administration. Sometimes database administration is part of development group because there are maybe there are like 5 developer, one of them is DBA, right? But as I said, 99.99% time you are not creating any table or you are not creating any database. Table will be there already for you to test. But still, if you want to know the formula, this is the formula. Create table name, and you see that column name, column name, column name. You see the data type. It's kind of Java. Remember, there were a lot of data type like int, string, right? Date, like a lot of type. But in SQL also, they have data type also. If you see here, this is one of the example. If you see create table persons, so this is one of the persons. Now, why I said W3 School will be perfect for you. If you see here, after each of this topic, there will be a place, try it yourself. So you can actually practice. So if I click on try it yourself, you see that this is something you will find similar stuff at your work. This will be similar stuff at your work where you will be writing query, and based on query, you will be seeing the result here. It's very similar to IntelliJ, right? So IntelliJ where you just write your Java code, then run it and see it is whatever you're displaying, right? This is called database IDE. Like, so for example, so where you will be actually checking your data. If you go back to this picture, right? Here, right? So this is called database workbench. So whatever I am showing here, this is a workbench. So workbench means like SQL, Microsoft SQL, their own workbench. DB2 have their own workbench. So if you, or Oracle has their own workbench, right? So those workbench has just a front end place IDE where you just write your queries or syntax, and you have an option to run. And when you run, like for example, you want to check some specific account information, all of this information will be here. So similar way, you can see you don't need any middle layer like internet connection. This testing, whatever I'm doing right now, even though this is a web-based application, but in real life at work, you don't need internet, and your laptop, right? You have this workbench option already installed, and this is already connected to with database. This is an internal connection, no internet required actually. So database will have direct connection with your workbench on your laptop, basically, so that you can directly go to this database and check how many table is there. Each table, how many column is there? Maybe your requirement saying that, okay, in customer table, there should be 12 column. There should be 12 column in customer table. Now you are going to customer table and figure out how many column is there. And you found that there are 10 column. So the 2 column are missing, right? But your requirement saying 12 column, you're actually going to database and say it is 10 column, 2 column missing. So this is a defect, you will be logging the defect. So this is a create table, and this is one of the examples. So you see that this thing, these are attribute, right? last name, first name, city, maybe state, maybe zip code. This is data type. So it's like similar to string. This varchar, you see that varchar? Varchar is kind of string. In Java, you saw string, right? String is holding name, right? And 255, what is 255 means? So you are saying last name cannot be more than 255 character long. 255 is too high, actually. In real life, you will see maybe 40 character long. In name, right? Name can, if you have like 255 character long name, this type of name, like how, like this is like not user friendly, right? If you have a first name and last name like almost like 2 line long, this is not user friendly. But it can be 255 long. If you are declaring here, right? You are declaring here what is the maximum length of the or the value, right? You are just declaring what is the maximum length of the value. So this way you can basically, if I run this, for example, this is currently right now cannot create, but in real life, if you see that city, and this is a format, this is a formula, right? Create table. Whatever table name you are creating, this is the name. This is the person, right? If you are creating order table, that will be order. Create table order. Create table student. Create table income, right? So whatever name you are creating, that will be there. Create table will be common. This is part of your formula. Remember I said syntax, query, or formula, same thing. So this is a formula. And going back. So this is the formula actually. This is the formula. You will have create table and then you, whatever name you are giving, whatever column name you are giving here, inside the parenthesis. And each of them will be separated by a comma. You see that there is a comma. Each column will be separated by a comma. And this is opening parenthesis, ending parenthesis. So another thing, you have to check primary key here. As I said, you see that when you're creating a table, you have to declare a primary key. Everybody can see, right?
Yeah.
So you are saying ID, the column name ID is the primary key. And it is already saying cannot be null. You have to provide ID. Based on your table, right? You can actually say if this field should have value or not. So this table, like whoever is creating this table person, this developer or DBA, whenever they're creating this table, they said, okay, ID is primary key and ID cannot be null. And also another logic, you have to have at least one last name. And last name also cannot be null. You have to have a last name. But it says age can be null. There is no restriction for age and first name. You see that? Whenever you say no null, that means you have to provide the value. And here you are declaring which one is the primary key. You see that? You can do both. You can do in 2 different lines or you can do in 1 line, no null primary key. So basically you are declaring which column is the primary key. So this is a formula. As I said, 99.9% time, you are not doing this in QA. This is just the informational purpose. So create will be most of the time, you are not doing it. So going back to where condition. So actually we have read. So far we figure, okay. So CRUD, right? So which saw C means create, we saw read means select, and update, right? Now we will check update also. Update you'll be doing sometimes for your testing purpose. Okay. primary key, create, drop, okay, update. Okay, so this one is another one, insert. So when you create a table, right? By default, the table is empty, right? There is no information in the table. But now you want to actually add information. So there is another formula, insert table. So insert information inside the table. You see that this is the table name. So whenever say insert into, right? This is the formula, insert into, and then whatever is the table name. So for example, remember we just created one table, for example, order. And now I'm giving you order table here, and then the values. Column 1, column 2, column 3, and values and columns. So basically, this value 1 is going to column 1, value 2 is going to column 2. So this is a formula basically. This is a formula. You see that here? If you see, this is a real formula, right? If you see that, insert into customer. So customer name, city, country is the value, and this is just the column. And now this one is actually is different because they are not giving the real value. So it is saying that check another table suppliers, and from the supplier transfer everything, these 3 column into this. So this is little bit complex actually, but as I said, this is just the informational purpose. I don't want to confuse you this one. So instead of that, I will actually check this one. This one is much easier to see. So here, right, I'm saying, so there are several columns, right? Customer name, city, and country. So supplier name, city, and country. And again, this is actually filtering more. Remember where it's saying not every country, just the Germany. Okay, no, this is actually little advanced, so I'm not going there. Okay, so going to update now. 1 second. Okay, here. So you saw create, you saw select as a create, and also you saw view, right? Read. Now delete. So when you say delete, right, this is a formula. Delete from table name and where condition. So now you want to delete some information. For example, you want to delete somebody's information whose name is customer name is, what is that? Around the horn. So this is the name, right? I want to delete this person. This row should be deleted. So what formula I will be using? You see that? Try it yourself. So I'm saying delete from customer table. This is the table name. And this is the part of your formula. And now you are giving condition where customer name equal to Alfred this. So there is a problem actually when you select this type of, when you do delete type of thing, right? If this is not common, always use the primary key. Always use the primary key means, now what is the problem here? If you see, this is the interview question. Why you will be using primary key for delete option? This is the interview question. Because in this table, right, as I said, if I say delete where first name is Mohammed, if there is like 300 Mohammed, everybody will be deleted. But I don't want all the Mohammed. I just specifically want where customer ID is 4 or 5, or where social security is 1, 2, 3, 4, 5, something like that, right? So you have to use primary key value for deletion. So this type of deletion, you have to use the unique ID. So if you have 100 test data and you want to delete only one test data, you have to delete that specific test data. Don't use this common name. If you use where city is Jackson Heights, city is Astoria, everybody lives in Astoria or Jackson Heights will be deleted, right? You don't want that actually. You want to delete some specific customer details, and that specific customer details either like maybe account number, social security, something like that, or specific customer ID, employee ID, those. So this is an interview question. If somebody asks when you delete, you will be deleting with primary key so that that specific person will be deleted from the table. Now, next one is update. So now, as I said, remember I said you are moving to California from New York. So now you want to update your address. You call to Amazon customer service or Chase customer service, and you're saying, okay, I recently moved to California and I want to update my new address. So the representative will be doing first, he or she will be asking you, maybe you are the right person or not, like your maybe social security or phone number. I don't know what is usually banks, right? Banks usually ask last 4 digit of social or your account number, right? Usually. So this is the formula for update. So you are updating specific field like address, phone number, right? Or maybe company you are working, this type of information you are updating. You are not updating your name, maybe, because your name will be still same. Unless you update your name by court issue or anything, like some people change their name. So if you see this example, try it yourself. Update customer, right? Now, you see that here, this is the right option. Used primary key, right? So if I just, for example, you want to use set address or city, address equal to something 1, 2, 3, 4, 5, something Astoria. You see that this one, right? And whenever you give 2 different attributes or 2 different value, always will be AND. In SQL, 2 different thing will be always AND. Set address equal to this is not 2D, and city equal to Frankfurt. For example, like this, like city. You see that? Where customer ID is maybe 1, 2, 3, 4, or whatever is customer ID. So now it will be updating accordingly. So now, if I forget to give this where, if I don't give where condition, right? Everybody's address and everybody's cities, like if there are like 10,000 customer in this table, everybody's address will be changed to this. Everybody's address city will be changed to this. You see that there's a problem. So you have to give condition, means you have to specify, is that specific to 1 person, 2 person, or everybody? So this is where condition you are giving. So far you saw this, right? All of these 4 uses. As I said, create, update, and delete. No more than 20% time you have to deal with. Maybe 10% time. 90% time you have to deal with R, that is actually select statement. So the goal is from today, actually, right? This is kind of will be also homework. start from select, right? Every topic is adding some specific condition. Now select, we already saw. This is a distinct. You see the distinct? What is distinct mean? So now in the table, right, you see there are total of, okay, let me go to try yourself, right? So you see that if I go to customer table, there are total of 91 rows. Everybody can see, right? There are total of 91 people in this table, customer. 91 customers in this table. You see that there's a lot of country are same. Maybe a lot of city are same. So now one of your verification will be that you know that 91 people and you want to know how many countries they are from. So now you will be using the word and query distinct. See that the word distinct? So you will be saying that, okay, select distinct. Distinct means there will be no duplicate. If there are 91 people coming from like 20 different countries, it will be displaying only just that 20 countries. No duplicate. So distinct will be basically displaying unique number. So how it works, as I said, this is customer, but we are not saying customer, we are saying distinct now. You see that? Before we saw 91, right? So now if I say distinct country, it definitely will not be 91 because you see that customer has 91 record. This 91 record definitely have the country, right? Because a lot of customer came from same country. If I run this now, only 21 unique country. You see that? 21 unique country. Everybody can see, right?
Yes.
Yes.
So this type of validation you'll be doing as a QA a lot of time. But one thing I want to show you because, okay, first practice maybe few more like this, distinct. So now your interviewer can ask why you use distinct. So basically the goal is each topic, right? There is a small topic, right? What is distinct doing? What is where doing? What is and doing? What is order by doing, right? So you have to know the distinct statement used to return only distinct or unique values. You see that those are distinct means unique values. Unique means if you see here, right? Those are unique country. There are no duplicate here. You're not gonna find Argentina twice, 2 times written here. So all the different countries, and they will be displaying only once. So if I go to next one, where we already saw, right? We are giving a where condition. Now, if you go there, right? This one, it says distinct country. So now I just removing distinct and I want to see how many people from maybe Mexico. So all I have to do from customer and write where. You see that this is the condition where, and you have to give exactly same column name. Like you see that C is uppercase, so you have to give uppercase. And then it's like Java equal to, you have to give single quotation, not double quotation. Now, you see that I said, show me all the customers who are from Mexico. So you see that this is the condition, just the condition. Before, if you run without where condition, you will see 91 people. But now you're saying, show me only people from Mexico. Run this query, 5 people from Mexico. I don't want country, I want everything. So if you don't want a specific column, right? You can give directly the star. Star means show me all the column. You see that? And if you want to give specific column, like address, then comma, city. Any column you want, you have to give by separated by comma. Address, comma, city, comma, maybe postal code, comma, country, comma, like this. So if I run this, I'm not gonna see everything. I will see only these 2 columns. You see that? Address and city. So who is doing this actually? So internally, remember database management system, DBMS, they are doing this. This is a software. Oracle has their like DBA, their DB2, like IBM, right? Microsoft SQL has their own. So this is database management system is basically communicating with this table and manipulating your data, taking care of this, all of this information you need. They are bringing when you searching, you are using this SQL, right? You want specific criteria, you want specific information, you can just search. You can update, you can delete, you can create, right? Everything is all of these functionalities that are information they're taken care of by those database management system. So what is the next one? You saw where condition. You can give actually 2 where condition also. If I give 2 where condition, I can say and country equal to Germany, maybe, right? Can I run this? It's not working. Okay. So, okay. Let me delete this. So, okay. So if you want to use, maybe I'm using the wrong thing. Okay. If you want to use 2 different country, you can actually use the word in and then give parenthesis. I'm just using comma. So for example, I want to see all the people from not only Mexico, another one, maybe I said Germany, right? Or maybe Canada. So now if I run this, I should see 5 people use from Mexico, right? There'll be maybe few more people from Canada also. You see that 8. So 5 from Mexico and 5 from Canada. So if you want to see here, you can see. You see that whatever you are just modifying exactly same query, select statement. You are not doing anything new. You are doing new means you are every time you are just adding some new information that what you are looking for basically. You see that Mexico, Canada. So now Mexico, Canada. So now there is another one here. You see that, and I will come back, but I'm going to order now. Order by. So by default here, right? If you don't give order by, what you see here, you see Mexico, you see Canada is mix and match, right? So now you are thinking, okay, I will give another country. Another country is maybe Argentina. Where is Argentina? Is this one? I'm giving Argentina also. Argentina is comma. Okay. So now I will see actually even more than, okay, another 3% from Argentina. So this is not sometimes user friendly. You want to see A on the top, right? B next is a alphabetical or numerical is order, right? You don't want to see mix and match, right? A should be coming first, then B, then C, anything, right? So this, when you want to see in order, you will be doing order by. You see that order by? Example, order by country. So if I just simply write this on order by country at the end, you will see this is displaying as order by. You can write in same line, or you can just go the second line also. Like for example, I can just go to second line, go to second line. It depends. One line is okay also. Sometimes if it's too long, just go to second line, break it down. Order by, you see that order by. Now I want to see this order by country, right? Like sometimes if you see income, like in the future, like if you are going to some table that has all the incomes, right? So who makes who makes more, who makes less? You can see this order by functionality, right? Order by, okay, country. Now I say country. So now if I run this, you're not going to see this mix and match. You'll see in order. You see that Argentina came first. So what is this order called actually? This is called ascending order. This is called ascending order. But what if you want to see A at the last? That will be descending order. So by default, when you write order by, it is automatically ascending, right? But if you want to see opposite direction, you have to write descending, DESC. If you run this, now you will see Mexico first, because if you see the order, Argentina is going last, Mexico first. There is only 3, right? M, C, and A. Out of M, C, and A, Canada is always in the middle, right? Mexico, then. So you can also write, even though this is by default, you can write ASC. ASC means ascending. Basically, is nothing. But even though you are not writing ASC, by default, it will be ASC. But if you don't want ASC, write here. Is this formula also written here, right? You see that? Either ASC or DESC. So this is order by, is very, very useful sometimes. You will be using. So now, and or not, right? So and means you are giving condition, right? When you are giving condition, then both condition has to match. So this is the interview question. What is the difference between and or? What is the difference between and or? We saw this in Java also. If else statement we saw very similar actually. But here, right? I don't want to mix up with this Java because it is, I think, is more straightforward than Java and easier. So and, right? When you say and, that means if you give 2 condition with and or 3 condition with and, your result should be retrieved with the accordingly with this all 3 condition true. So basically here is 3 condition, right? Condition 1, condition 2, condition. All 3 condition, if all 3 conditions true, then you will see the result. Or means you have 3 condition, right? Only 1 condition need to be true to get the result. And not means, okay, now you see that not. So not means you don't want to see this specific condition. So now I'm going back here, right? I'm saying this is, I'm just, okay. if you see this knot, right? Actually, okay. So all you have to do just where not. So what does that mean actually? So if you see, okay. And deleting this also, actually I can keep this. So I'm saying I want to see all the countries, people from everywhere except these three. So I don't want to see any people from this Argentina, Mexico, and Canada. So if you run this, you see every people, like before we saw 11, right? 11 people were from these three countries, 91 people total in this table. So you can clearly see it is matching your expectation, right? 11 minus, so 11 was subtracted from 91, right? Then 80 left. So you're not going to find any people from Mexico, any people from Canada, or any people from Argentina here. So it's like for all this filtering purpose. So you are filtering out. You are filtering out that what you are specifically looking for. So this way actually IRS works, right? IRS will have a lot of specific condition here. Okay, who missed to file tax return last 2 years, right? Who missed to file tax return last 3 years? Who didn't pay the penalty? Who made money like more than 200,000 but did not pay tax, like something like that. So you are actually giving the condition here and getting the information. So based on those conditions, when they see the result, they send everybody maybe mail or something with the penalty or anything. You see that all of this is part of filtering purpose actually, basically, to get the correct result from database. So now I'm going back to actually MLB again, how it works actually. So this is Major League Baseball, right? This is their website. So this is all of these stats. For example, who is scoring what, right? Who is scoring what? Who scored more home run? Who scored more runs? Something like that, right? How they're getting this actually? This is by default, everything is here, right? Now, if I say, show me the statistics from year 2020. What does that mean? That means they are going to some database and saying year equal to 2020, right? Where like something like here, like they're just saying in mlb.com equal to 2020. You see that? Like this type of condition they are using here, right? You see that? Now, in 2020, I'm saying who is number one for you see that every team has the condition, right? Like every country. So I'm saying in 2020, in New York Yankees, who was the top? You see that? This guy was the top. It's on much less data, right? So you are filtering. You are basically filtering. So all of this filtering is part of your DBMS, right? Database Management System. And this is all about select statement. It's all about select statement. And select means CRUD. In CRUD is R, read. Basically read access. You are searching data. Make sure this data is displaying correctly. So if I search data for Gilo, Queens or Astoria. So I'm searching data for Gilo, Astoria. That means I'm saying, please find me all the open houses in Astoria. this information, right? Internally, they're actually filtering and they're saying display all the data, only anything inside the Astoria zip code. He said 361 result is coming from Astoria. And these are done from this select statement. And all of these are select statement. You see that select, right? Order by, insert, null, update, delete, select, top, everything is select statement. Some of them are here. You see that max, min, these are very important also. These are also built-in functionality inside the SQL, right? If you go try it yourself. Now you are saying minimum price, right? So if I go to product table, where is the product? Oh, this one, okay. Actually, okay. I'm going to product table here. Okay. You see that product? Every product has different price, right? Some of them $6, some of them $15, some of them $62, some of them even $97, right? So if you see that this function minimum, maximum, average, sum, count, so that you can figure out which one is the most expensive price, which one is the less expensive price, right? Which one is, you can give the price range also, right? All of these. You see that in this table, minimum price, right? The lowest price was $2.50. I don't know where is that. It's somewhere in here. You will find some product has, you see that this one, $2.50. And it seems like $263 one is the maximum. So if I just simply write, instead of min, just max. If I run this, you see that 263. So this is just like manipulation of your select statement. So this is another one is very important. Wild keys. Like this. So now you have basically percentage sign, right? So you are saying find all the product where I'm saying product name. So if you go now this symbol. So percentage sign, you don't have to give the entire name. All you have to give, you see that where product name, like, the word like, and then percentage sign. From actually this one, product name, like. So what does that mean? Okay, if I say any product name has this word, Kajun or something. So I'm saying this product has this one. You see that I'm saying any product has the name Kajun in the middle. Display all of this product. If I run this is an error. Actually, why this is error? It should be same. Okay. Oh, there is a reason actually why. This is like a string, right? I did not give this quotation, right? I have to give the quotation. I forgot to give the quotation. Where is that? You see that I gave Kajun, but I didn't give the single quotation. I have to give single quotation. See that? That's why it's give me error actually. It's supposed to work. So you see that? Now I'm saying anything has a GUN in the middle. One. So before it did not work because it is a uppercase C, right? I gave the lowercase c. If I give uppercase C, it will work also. It did not work. Why it did not work? It's supposed to work. Also, you are saying that, okay, find all the product name whose first 4 letter is this one. So this is like wild key. So just HEF, right? HEF. Oh, it's starting with CHF. That's okay. I have to give this symbol both side. Okay. So now you can see, right? HEF, there are two people, right? There are two product has HEF in the middle, right? So you see that this percentage sign will be like counted as just wild key, but it means this percentage sign will be basically count for anything before H, and this percentage sign will be acceptable for anything after F. So now if I say this is C, it should also work. It's still, it should give this 2. You see that this is also giving this 2 because this is following this formula. This formula. Now, if I want something ending with X. So anything ending with X, I want to know all the product name that ending with X. What do you have to do? Just percentage sign and X. That's it. 3 product has ending with X. If you want to just simply, if you want to see everything from this product, just simply run this, select all from product. See that everything from the product. Total 77 products are here. So now if you say, okay, anything has O in the middle, find everything that has O in the middle. Oh, actually, I'm saying where. Like, so I'm saying anything has O in the middle, display all of them. %2 sign is not working. I don't know why. Is that O or 0? I give 0 maybe. Oh, no, yeah, I give 0. That's why it did not work. Okay, yeah, it is working. Instead of O, you see that every name of the product has somewhere in O in the middle. But this is just the filtering purpose. So I think this one you can practice when you get a chance. So one thing I just want to see, this is the most important one for interview point of view also, and also work point of view, joining, inner join. So anytime you actually, so first of all, I want to actually just explain the joining little bit. because this is very important. Okay, everybody can see. So joining is very important because joining means you are getting data from more than one table. Maybe you are getting data from 2 table or 3 table. So then you have 4 types of joining. One is inner joining. So this is the most common one. So inner joining means whenever you have 2 table, the common material from these 2 table or common information from these 2 table will be displaying. You want common information from these 2 table. Left join means you see that from the picture. Everything from the left side of the table and also anything common with this right table also. Right joining, very similar to left join, everything from right join plus common stuff from left table. Full join means you want all the information from both table. But as I said, these 3 are almost you're not gonna work with. Most of the time, inner join is the one that you will be working with. So I'm going to inner join and how it works. So inner join will be completely working. Remember foreign key. You actually know now primary key and foreign key, right? There is a specific formula for inner join. So there is separate part. So when you do inner join, right? So you have, for example, you have 2 table here. Everybody can see my screen, right?
Yes.
Yes.
Okay, so I'm dealing with now, so far, like previous other examples, we actually worked with only 1 table. We didn't go to more than 1 table. So now my requirement is, or my test scenario is, use both table, order table and customer table, and find order ID and customer name. I want to see that. So order ID is coming from order table and customer name or customer details are coming from customer table. So I want to do something else. Let me check. So customer, right? So I want to see customer name and address or customer city or just address. So what you're doing here, actually this one. Customer dot address. Okay, so I want order ID and what else in order actually? Customer address, orders, okay. So not only order ID, I want order date also. I want this one also. Okay, so what is that actually? So when you use more than 1 table, right? When you deal with more than 1 table, so you always have to mention the column with a dot from this table. So I'm saying what we did before. Before we said select column name, right? But now we are dealing with more than 1 table. We are dealing with more than 1 table, right? So when we deal with more than 1 table, we have to mention this column is coming from which table. So now we are dealing with ordered table and customers table. Now I'm saying I want to see order ID from order table, order date from order table, customer name from customer table, customer address for customer table. This part you understood?
Yeah.
So this is just straightforward. Only thing you have to mention the table name also with the column, with the dot. So now from which table? Order, and you have to write which table it is joining with. Customers table. You can also write customers inner join orders, right? So it will be exactly same. But I'm saying, okay, now I want this information from order table inner join customer table. So since you are joining, right, you have to write this. This is the part of joining. This is the extra layer that's saying you will be joining order table with customer table. This part you understood, right? This is just the part of formula. And this is, you have to figure out the foreign key. Remember we said the common column for these two tables, you must have to give the common column name here. So you are saying that I am joining, but based on what? Based on this condition on orders.customer ID equal to exactly same as customers.customer ID. I'm saying that customer ID in order table is exactly same as customer ID in customer table. Did you see that there is a foreign key here? Everybody?
Yeah.
So this is the only tricky part actually. You have to figure out the foreign key, and based on the foreign key, you have to create a relationship, how these two tables are related. So now if you run this, you will see all the information from both tables. You see that? You are getting all the common information from both tables. You are getting order ID from order table, order date from order table, customer name from customer table, address from customer table, based on this relationship. So this is your testing. Now your test case says, okay, 196 is the expected value. You see 196 expected value is right. Now you randomly checking, okay, order ID 103, like 10308. So now you can cross check actually. If you cross check here, right, order ID equal to 10308. So now I'm cross checking, going to order table, and I'm saying where order ID equal to if I run this. So this one is not displaying anything, right? It's something maybe internal problem, but in real life, right? If you see, okay, you see that order ID, there is a lot of order ID, right? And you see order date. So you have to also sometimes cross check, means anything you see here, are those right information or wrong information? You have to check, sometimes cross check. So order ID, so now you have to make sure that, okay, this person is present in customer table separately. Just cross check. But this is the joining. So this is a part of interview question. So how you join a table, two table? How you join two table like this? So you can actually, so what happen if there are 4 table or 3 table? So you can do exactly same thing here. Like you see that, like for example, order product, right? So you can say, now you are checking product ID and order, right? If you see order, order has anything that has product or supplier. Or order details, there is another table, right? Order details. So order details has order ID. That means I can actually connect these two table with order ID also, order details, right? You see that order table has order ID, order details table also has order ID. So I can easily connect three table here, right? So how you can connect? So now from orders, so now I can see inner join, I can say order details. What is the spelling of order details here? Order details. Okay. So this is inner join order details. I can say on similar thing I can say, right? Like not this exactly. So if I say order on orders on order ID, if you go back, order ID, right? Order ID. Equal to order details dot order ID. So both of you actually, did you see that how I am just connecting now three table together?
Yeah.
So same way you will be doing 4 table, 5 table, but usually for interview, usually you're not going to see 5, 6 table. Usually they ask 2 tables joining. Sometimes they can ask 3 table also. But if you know the logic, right? What is the logic? Inner join and then based on what? Inner join based on what, right? Based on foreign key, right? The common foreign key. Inner join based on common foreign key. So this is the logic you have to just understand. You are joining the tables based on what? Based on 2 common column, right? Based on 2 common column. So this is actually joining. So this is very important. So I think we are actually good for today. So now I think you all have like basic knowledge about database testing and basic knowledge about SQL. So if you get a chance, as I said, watch one of these 2 video. I'm just sending you in the chat right now, but I should send you this whole document to you both, actually everybody. Actually, what is that? I should, okay. In the chat I'm sending right now, just in case you can just save it for now. So this is 3 hours course, right? Just watch one of them. It will be covering everything about SQL, everything about this database testing. You got it?
Yes.
So I think we don't need to go every single topic for now. I think just try from your side just go to each of them and try yourself. Just try to just review. First, watch this one of this video. And then do some practice. If you have any question, you can always ask WhatsApp or next class. So I think if you don't have any question, any concern, maybe we can close today's call.
Okay, thank you.
Okay, thank you.
Okay.
Thank you.
Thank you. Have a great rest of the weekend.
You too. Bye-bye.